So guys, in this lecture we are going to study entropy of the system. हम यहाँ entropy के सारे concepts क्लियर करने जा रहे हैं. entropy में जो भी questions आपके competitive exams में आ सकते हैं वो सारे हम इस टॉपिक में क्लियर करने जा रहे हैं. बहुत ही ज़्यादा इम्पोर्टेंट टॉपिक है entropy of the system. Thermodynamics का लेक्चर 11 है ये. This is lecture 11 of thermodynamics, that's entropy of system. Now इस टॉपिक में हम पढ़ने जा रहे हैं what's entropy of the system, what type of properties entropy of the system, and entropy for different thermodynamic processes. We will combine here first and second law of thermodynamics as well. We will take some basic equations which I have already explained. We will take advantage of those very equations as well. So let us study what's entropy. Now what's entropy? Entropy is actually unavailable energy. It's unavailable energy. It's unavailable energy per absolute temperature. Per absolute temperature. It's unavailable energy per absolute temperature. It's unavailable energy per absolute temperature. Now heat is a form of energy, therefore it's unavailable heat. Make notes with me. It's unavailable heat per absolute temperature. Per absolute temperature. It's unavailable heat per absolute temperature. Now where does this definition come from? There is a law of thermodynamics, that is second law of thermodynamics. Second law of thermodynamics states that there are number of statements of second law of thermodynamics. Basically we are going to explain second law at the end of this topic from entropy. Now second law of thermodynamics gives one of the statement like this: you can convert work into heat. Work into heat. We can convert work into heat. 100% work into heat. But 100% heat cannot be converted into 100% work. Into 100% work. 100% heat cannot be converted into work. Means there is some heat which is unavailable heat. There is some heat which is unavailable heat. That unavailable heat per absolute temperature, that constitutes our entropy of the system. Now unavailable energy or unavailable heat, let me write it as Q. This is Q unavailable heat or Q unavailable energy. Per absolute temperature means divided by temperature in Kelvins. Absolute temperature means temperature in Kelvin. This is Q divided by T. This is equal to change in entropy del S. Why change in entropy? Why not equal to entropy of the system? Now we will take these terms. This is actual definition of entropy, where from we get the equation del S is equal to Q by T. Now what is in common sense, what's entropy of the system? In common language, entropy is just, it is randomness. It is randomness. It is disorder. Randomness or disorder of the system. Randomness or disorder of the system. Now what do we mean by disorder of the system? Let us take a system. In this system there are certain molecules of the gas. Now they are in a certain ordered manner. If I apply heat to the system, this unavailable heat, if I apply heat to the system, what happens to the system? What happens to this system? Kinetic energy of these molecules gets increased. With the application of heat, rotational energy gets increased. With the application of heat, every type of energy gets increased: kinetic, rotational, vibrational, electronic. As a result, what happens? These bonds between the molecules, they get broken down. If the bonds get broken down, molecules move far apart from each other. Means there is disturbance in the molecules. There is disorder in the molecules. There is randomness in the molecules. Now the molecules are arranged wherever they wish they will go. This is called disorder of the system. Now entropy is this disorder of the system. Then what happens to the entropy when we increase temperature? If we increase temperature, what happens to entropy? If we increase temperature, entropy increases. entropy increases. If we increase temperature, entropy increases, means S increases. S is entropy. If T increases, S increases. Now then, why is T in the denominator in this equation? With increase in temperature, entropy increases. But this equation tells something else. If we increase temperature, change in entropy of the system decreases. Now this is change in entropy and this is entropy. With increase in temperature, disorder increases, randomness increases. But it has been experimentally proved that, it has been experimentally found that with increase in temperature, change in entropy decreases. With increase in temperature, if we increase temperature, del S decreases. Del S decreases. Change decreases, not entropy decreases. With increase in temperature, entropy increases. But with increase in temperature, change in entropy, del S decreases. This has been experimentally proved. It has been found at low temperature values, delta S, change in entropy, was found to be high. And at high temperature values, change in entropy has been found to be low. That's why it is in the denominator. Del S is equal to dQ divided by T. Because at high temperature values, if we supply same amount of the heat, for same amount of the heat, if the heat supplied is same, at high temperature values, entropy of the system is low. Change in entropy of the system is low, and at low temperature values, change in entropy of the system is high. This is about why the T is in the denominator in this equation. Now what about this change in entropy? Why we use change in entropy? Why do not we use only entropy? Because absolute value of entropy cannot be determined. Absolute value cannot be determined. Absolute value cannot be determined. We cannot determine absolute value of certain thermodynamic quantities like internal energy U, like enthalpy H, like Gibbs free energy G, like Helmholtz equation F or A, like entropy of the system S. These are all state functions. Their change is determined del U, their change is determined del H, their change is determined del S, their change is determined del A, their change is determined del S. Now this thing we have discussed, we are discussing this thing now. Later on we will discuss these two things. Now absolute value cannot be determined, but we can determine change in entropy. Change in entropy, del S, that is del S, change in entropy. We determine change in entropy, that's our del S. We determine change in entropy. Change in entropy of the system is determined. Now how can we determine change in entropy? Now change in entropy del S is equal to, when we talk about change, means there is initial and final state. Now let us take a system. This system has this type of structure. There are certain molecules of the gas. Let the initial entropy of the system is S1. Let the final entropy of the system is S2. Therefore, this is final entropy of the system. This is initial. Change in entropy is equal to del S. Therefore, del S is equal to S2 minus S1, or S final minus S initial. S final minus S initial. What does this S final and S initial mean? We can apply it to, it means that we can apply it to thermochemical equations. For example, if we have an equation A plus B, or A gives B. Now A is our reactant, it's our initial state. B is our product, this is our final state. If we want to know entropy of this reaction, then del S is equal to entropy of B, that's product S, minus entropy of reactants, that's A. Therefore, for a chemical reaction, del S is equal to entropy of what? Product S minus entropy of reactants. This can be applied to thermochemical equations. Now see, our entropy is a state function. Every state function is exact differential. Therefore, we can differentiate this. We can differentiate this. ds is equal to dq divided by t. Why we have not differentiated temperature? Because it is absolute temperature over here. It's unavailable energy per absolute temperature, not change in temperature, per absolute temperature. From this we can get an equation dq is equal to TdS. Now this is our equation which we have got. Remember this equation, we will make use of this equation. Now see, entropy is a state function, it's exact differential. Every state function is exact differential. Now if we have a cyclic process means we have a process like this. This is our cycle. This is from initial state A to state B, and then we come back to state A. Now entropy, let it is S1, let it is S2. What is change in entropy in a cyclic process? For a cyclic process, change in entropy, change of every state function is equal to 0. Therefore, it is equal to 0. Now this is about definitions of the entropy. Now let us make use of this entropy and we apply this entropy to different thermodynamic processes. Now let us apply this entropy to different thermodynamic processes. Entropy of reversible process. Reversible processes. When the process is reversible, entropy change to different thermodynamic processes. One I will take reversible process and the other I will take irreversible process. Irreversible process. Now what is our process in thermodynamics? In thermodynamics our process consists of two parts, system and surroundings. This is system and this is surroundings outside it. Let this is surroundings. Now see, system will have its own entropy and surroundings will have its own entropy. This is whole universe for we people. If we want to know entropy of this universe, then entropy of universe will be equal to entropy of system plus entropy of surroundings. Now what will be entropy of system? Now see, if we supply Q quantities of heat to the system, now heat absorbed by the system is taken to be positive, then entropy of the system becomes Q divided by T. And if the system absorbs Q quantity of heat, it releases heat to the surroundings, then entropy of the surroundings decreases. If entropy of the system increases, entropy of the surroundings decreases. Now see how? Because entropy of universe is equal to entropy of system plus entropy of surroundings, or we can say entropy of system is equal to minus entropy of surroundings. Therefore, if it is Q by T, then entropy of surroundings will be minus Q by T. If we supply same quantity of heat at same temperature, because in reversible process temperature is kept constant. Now taking temperature constant means this temperature and this temperature is equal. Therefore we can write Q divided by T minus Q by T, it will be equal to 0. That means delta S of universe is equal to 0 for what type of processes? For reversible processes. This is entropy change for reversible processes. Reversible processes. For reversible processes, delta S of universe is equal to 0. For reversible processes, delta S of universe is equal to 0. Reversible process means whatever entropy is of the system, opposite to that will be of the surroundings. Then the process will maintain equilibrium. Reversible process I have already discussed in my lecture 2nd or lecture 3rd of chemical thermodynamics. Now what about irreversible process? In irreversible process, temperature changes. Let us consider an irreversible process. Now this is system for we people. Let the temperature of the system is T2, high temperature, let this is high temperature, and let the heat of the system is Q. Now this system releases heat to the surroundings, means work is done by the system. This is our surroundings. Let the surroundings is at low temperature T1, let this is low temperature. Now this system releases heat to the surroundings, therefore if system releases heat, it will be taken as negative. Therefore, in this case, delta S system will be equal to minus Q by T2. And delta S surroundings, since heat is given to the surroundings, its heat will increase. Therefore, delta S surroundings will be equal to plus Q by T1. Now making use of this equation, delta S universe will be equal to minus Q by T2 plus Q by T1. Now let us take this thing constant. Let us take Q constant. If we take Q outside of this, take Q as constant, what remains over here? 1 divided by T1 minus 1 divided by T2. This is our equation. Now let us assume that this is T1. Let us assume that T1 is greater than T2, means temperature of the system is higher than that of this. Or we can write it like this: if T1 is Q into T2 minus T1 divided by T1 T2. Now in this we have assumed that T2 is high temperature. Put it differently. In this T1 is at low temperature. Now since T2 is greater, if our T2 is greater, this term, if T2 is greater than T1, this term comes out to be positive. Therefore delta S of universe is equal to positive. Positive means it is greater than 0. Delta S of universe is greater than 0. In which process? In irreversible process. Therefore entropy in reversible process and entropy in irreversible process are different. Entropy in reversible process always equal to 0, and entropy in irreversible thermodynamics is greater or equal to 0. If we combine these two equations, then what we will get? Delta S universe is equal to delta S system plus delta S surroundings is greater or equal to 0. This becomes our condition. This is the condition when our process will take place, means this is the condition for spontaneity of a process. Spontaneity of process. If you can't remember this, what are the conditions for spontaneity of a process? In the coming after 2 or 3 lectures, I will discuss tricks with you how to remember these conditions for spontaneity of a process. Now what is spontaneous process? Spontaneous process is that process, spontaneous process which occurs on its own, which takes place on its own, जो खुद ही हो जाती है, which takes place on its own, or by small incision, or by little incision, or by little incision. Little incision, that is the spontaneous process. Opposite of this is also true. If we have non-spontaneous process, that's not favorable process, that will not take place on its own unless you apply temperature conditions to it. Now let us make use of other conditions. Now we have discussed it up to now. What's entropy in case of reversible process? Thermodynamical reversible process. Entropy of universe, delta S universe is equal to delta S system plus delta S surroundings is equal to 0. And we have discussed irreversible processes. For irreversible processes, delta S universe is equal to delta S system plus delta S surroundings is greater than 0. From these two conditions, we have shown that delta S universe is greater or equal to 0. This thing we have shown. Now what about adiabatic processes? We have shown that ds is equal to dq by t, or determining dq from this, dq is equal to t ds. Now from first law of thermodynamics, we know that dq is equal to du plus pdv. This is the equation of first law of thermodynamics, which I explained in lecture 4. Now what is dq? dq is equal to tds. Substituting value of dq in this equation, let this is equation first. Substituting value of dq in this equation, tds is equal to du plus pdv. Now this becomes one more form of law. This law is known as, this equation constitutes second law of thermodynamics. Now let us determine entropy change in adiabatic process. Number third process is, this was first process, this was second process, and number third process adiabatic process. Adiabatic process. Now for adiabatic process, neither heat enters the system nor it leaves the system. Q is equal to 0. Now we know that our dq is equal to TdS. If our, for adiabatic process, dq is equal to 0, that is TdS, that is entropy, del S is equal to 0. Means for adiabatic process, dq is TdS or del S universe is equal to 0. Now one more process, cyclic process. So cyclic process I have already shown. For cyclic processes, all state functions are 0. Therefore del S is equal to 0. Now let us discuss more factors, more applications of this entropy. How can we apply this entropy to different processes? To isothermal process, isobaric process, isochoric process. Now see, we know that ds is equal to dq by t. ds is equal to dq by t. Now from first law of thermodynamics, dq is equal to du plus p dv. Substituting value of dq over here, now it will be equal to, dq will be equal to du plus p dv. This I have got from first law equation. Therefore dq is equal to du plus p dv divided by t. Or I will write it like this. If I differentiate this equation, then if I integrate this equation, then integral of ds is equal to integral of dq by t. Therefore integral of ds, it will be equal to s, that is change in entropy, del S between the limits s1 and s2. Or let me write it, integral of ds is equal to du by t plus p dv by t. Now making integral of this equation as well, we can get integration of this. Now see, du divided by t plus p dv divided by t. Now we know that du is equal to ncv dt. This thing I have already explained, where from this we get this equation. Change in internal energy with respect to temperature is equal to heat capacity at constant volume. Now substitute value of du over here, we get integration of ncv dt by t. Similarly, we know that PV is equal to nRT, P is equal to nRT by V. Substitute value of P over here, we get plus nRT dV by V. nRT by T dV upon V. Now see, T and T will go. Now integrate this equation. We have to bring integration of dt by t, dt with respect to temperature, dv by v. Therefore our n is constant, cv is constant. This is integration of dt by t. Our n is constant, r is constant. This is integration of dv by v. Now integration of dt by t between the limits t1 and t2, upper limit and lower limit, v1 and v2. Now this is between S1 and S2. Now what will be this equal to? S2 minus S1, that is del S. Therefore del S will be equal to NCV integral of dx by x. Now see, integral of dx by x. Integral of dx by x, it will be equal to ln of x. Integral of dx by x is equal to ln of x between the limits x1 and x2. Therefore it will be equal to ln of x, x1, x2. Similarly, integral of dt by t will be equal to ln of t between the limits t1 and t2. Similarly, integral of dv by v will be equal to ln of v plus nr ln of v between the limits v1, v2. Now let us see what will happen to next. we will get del S is equal to NCV ln of T2 minus ln of T1, ln of T2 minus ln of T1, upper limit minus lower limit, plus NCV NR ln of V2 minus V1. Now what is this? Ln of A minus ln of B. Ln of A minus ln of B is equal to ln of A by B. Therefore, we get NCV ln of T2 by T1 plus NR ln of V2 by V1. This is the required equation for entropy of the system. We can change this equation as well. We know from Boyle's law, P is inversely proportional to V, or P1 by P2 is equal to V2 by V1. Now substituting value of V2 by V1 over here, we can get one more equation. Del S is equal to NCV ln of T2 by T1 plus NR ln of P1 by P2. Now these are our required equations which we apply to different processes. Now for isothermal process. Now this is our equation first, this is our equation second. If you cannot understand what is CV, what is this ln of T1, T2, then do watch my previous videos. You will get all knowledge about these things. Now see, for isothermal process. Now number first process, for isothermal process. For isothermal process. Now for isothermal process, change in temperature is equal to 0. Matlab, I mean that T2 is equal to T1 is equal to T. Therefore, this term becomes equal to 0. Del S becomes equal to NCV ln of T2 by T1 plus NR ln of V2 by V1. Now this term becomes equal to 0 for isothermal process. Therefore, del S is equal to NR ln of V2 by V1. Now question has been asked 4 marks in CSIR net exam. What is change in entropy of the system for isothermal process directly proportional to its ln of V2 by V1? The options was, one of the option was ln of V2 by V1, other option was only V2 by V1, third option was ln of V1 by V2, and the fourth option was V1 by V2. It's ln of V2 by V1. Now number second process, isochoric process. What are isochoric processes for which volume remains 0? V2 is equal to V1, that is change in volume is equal to 0. Therefore, this term becomes equal to 0. If this term becomes equal to 0 for isochoric process, del S will be equal to NCV ln of T2 by T1. Now one more process is isobaric process. Where should I write it? Over here. For isobaric process. Isobaric process. For isobaric process, del P is equal to 0. We can make use of this equation. Therefore, our del S becomes equal to NCV ln of T2 by T1 plus NR ln of P1 by P2. Now this term is equal to 0. Therefore, for isobaric process, it becomes equal to NCV ln of T2 by T1. Here we come with the conclusion that for isochoric and isobaric process, change in entropy is always equal. NCV ln of T2 by T1, NCV ln of T2 by T1. Thanks for watching this video. This was very important video. From this lecture, there are a number of questions that can be asked. This is a favorite question. This is very important 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 question. And this is very important equation. Now thanks for watching this. If you like my lectures, then please do subscribe my channel. Thank you.